Okay, let's move on to the third page. First one is another simplification of a radical. And what I have is I have the square root of 3 over 3 times the square root of 4. Well, the square root of 4 is a perfect square, so let's just change that to 2. All right, so that's going to give me the square root of 3 over 3 times 2. That would be equal to the square root of 3 over 6. Now the next one, I have a square root of 50 in the denominator. Let's just work this one way. And let's go ahead and just take the top and the bottom times the square root of 50. We won't simplify the denominator first. It's not going to be too hard to work with. So I have 6 times 50, that's going to be 300, and that's going to be under a square root sign in the numerator. And the denominator will be the square root of 50 squared. So now then the numerator, I can simplify that into 100 times 3, and the denominator, the square root of 50 squared, is 50. Now in the numerator, the square root of 100 is 10, so I can go ahead and remove that. So I will have, it should be 10. So I'm going to have 10 times the square root of 3 all over 50. And then I can reduce the fraction 10 over 50. So that would be the square root of 3 all over 5. Here I have a subtraction of some polynomials. So what we're going to do here is we're going to distribute the subtraction sign in. So I'll have x cubed plus 6x to the 4th minus 5. Now the subtraction will distribute to this negative 5x to the 4th, making that plus 5x to the 4th. The subtraction will distribute to 6x cubed, making that minus 6x cubed, and the subtraction distributes to the 6, giving me a minus 6. Let's combine like terms. Okay, now we're going to look and see what the largest exponent is first. Oh, I have a 4th power, and I have a 6 to the x to the 4th and 5x to the 4th. That's going to give me 11x to the 4th. Let's see if we have any cubes. Well, I do. I have an x cubed minus 6x cubed, so 1x cubed minus 6x cubed is minus 5x cubed. And lastly, I look to see if I have any squares. I do not. And let's look then at the numbers. I have a minus 5 minus 6. That's a minus 11. Okay, the next one is also an addition and subtraction of polynomials. So I have a minus 1 minus 4x squared minus 4x to the 5th. Now distribute the plus in. Plus 2x squared. Distribute a plus to a negative 5 is a minus 5. And distributing a plus to a minus 5x to the 5th is minus 5x to the 5th. Okay, so let's go ahead and pull out the largest exponent terms. So I have a negative 4x to the 5th and a minus 5x to the 5th. That's a minus 9x to the 5th. Let's see if I have any 4th powers. I don't. Any 3rd powers. I don't have that either, but I have a couple squared terms. I have a minus 4x squared and a 2x squared. So minus 4 plus 2 would be a minus 2x squared. Now let's look at the numbers. I have a negative 1 and a minus 5 here. Minus 1, minus 5, minus 6. Okay, let's do some end behaviors. All right, so what I have is I have an even degree, and there's a plus. So it's an even degree with a plus. Well, an even degree are either going to end and start in the same direction, and they'll either go up or down like that. So the plus sign means that we're going to have one that starts high and ends high. So we could write that as f of x goes to infinity, a plus infinity. The y is going upward as the x goes very far to the right, left, as x goes to a negative infinity. And then we have that the y value is going to also go toward infinity up here as the x goes very far to the right to a positive infinity. Okay, let's look at the next one. And we have another even coefficient, so that's either going to end, start in the same direction going up or down. That negative sign is going to mean that it's going to go downwards. So what I'm going to have is similar to before, except the y values are going toward a negative infinity. Okay, so you can see that in the answer that's here, the y's are going toward infinity. Okay, the next one says to factor. Now we have a 0 there. I think that's probably just the way the software brought that up. So we're just going to go ahead and factor it. We'll leave the 0 there. So the first one, notice I have 4 terms, and it's an x cubed. Cubic squared, first power, and a constant term. So I think I can use grouping there. So let's take a look at the first two terms and kind of mentally divide those. And I could pull an x squared out, and I would get x minus 4. So I would have to have x minus 4 on the last part and see if that works, if I can pull anything out. And sure enough, there's already an x minus 4, so I would put plus 1. So my factors would be x squared plus 1, x minus 4 equal to 0. Okay, the next one is also a quadratic form of the form of fourth power. The next one is a fourth power, squared, and a constant term. That's called quadratic form. And I factor it just like I do a squared, except that my factors are going to be x squared factors, and I may have to factor those again. Okay, so it doesn't have a coefficient in front of the x to the fourth term, so maybe this is simple factoring. Let's look for two numbers that add to 14 and multiply to 49. That would be 7 and 7. So plus 7, plus 7. Now, I can't factor those two x squared terms any further. They're not a difference of squares. So we can just write this as x squared plus 7, since both those factors are the same, squared equal to 0. And that's the end of that page.